Well, our next example, we're actually getting easier than the previous examples. Here's a system of three equations of three variables. But notice that equation 2 and 3, the coefficient of x1 is 0. The x1 doesn't even show up. So one way to solve this, and I think it would be the easiest way, would be to just take equations number 2 and 3. They don't even have x1. And what we have here is in 2 and 3, we have a system of two equations with two unknowns. We'll solve it just like we did in the previous section. Once we get the x2 and x3 values, then we'll just go up to equation number 1 and solve for x1. So this one is really going to be very simple. It'll be more of a review of the previous section. All right, well, what I'm going to do is take, say, equation 2. Rewrite it. x2 minus x3 equals negative 1. Well, I would like equation number 3, I'm going to multiply it by negative 1 so that it will be a negative x2 when I write it underneath here, and we'll eliminate the x2 completely. So I will put negative 1 times equation 2. Sorry, that's equation 3. That's equation 2 right there. Okay, and if I multiply negative 1 times equation 3, I get negative x2 minus 5x3 equals negative 14. Add these two equations together, and the x's will cancel out, and we get negative 6x3 equals negative 15. So we divide both sides by negative 6, and that would give us x3 equals negative 15 over 6. Let's see, negative 15 over 6, 3 goes into both of those numbers. The negatives just cancel out. So 15 over 6 would be 5 over 2. Okay, so that's one of the three variables we need. Now we can easily get x2 by just plugging it in to either equation number 2 or equation number 3, either one. I will plug it into equation number 2. So I would get, I'm going up here, x2 minus 5 over 2 equals negative 1. All I did is replace x3 with 5 over 2. So that implies that x2, if I add 5 halves to both sides, I get negative 1 plus 5 over 2. I just added 5 halves to both sides. Well, x2, that means, is equal to negative 1, well, 1 is 2 over 2. So I'm going to put negative 2 over 2, because that's equal to negative 1, plus 5 over 2 gives us x2 equals 5 minus 2 is 3, 3 over 2. All right, well, we solved for x2, we solved for x3. Now we have to go back to equation number 1 to solve for x1. So let me rewrite x1, or equation number 1, as x1, plus 2x2 would be plus 2 times 3 halves, plus x3, which would be 5 halves, equals 3. So that gives us, running out of room here, but I'll continue to the right. The 2 cancels out over here. 2 is just 2 over 1. So the 2's cancel and leave you with just a 3. So x1 plus 3 plus 5 over 2. 3 plus 5 over 2. That's 6 over 2 plus 5 over 2. Or 11 over 2 equals 3. So all I did is add the number 3 to 5 over 2. So we end up with 6 over 2, which is equal to 3. 6 over 2 plus 5 over 2 is 11 over 2. So now I just need to subtract 11 over 2 from both sides, and we'll have x1. So let me come way over to here. x1 equals, how do I want to write that? I'm going to skip a step here. I'm subtracting 11 over 2 from both sides. So this is going to be x1 equals negative 11 over 2 plus 3. But I'm going to write 3 as 6 over 2. So I have like terms. And that gives us x1 is negative 11 plus 6 is negative 5 over 2. So I needed more room than I thought I would. So I'm going to write the solution x1, x2, x3 right up here. x1, negative 5 over 2. x2 is 3 over 2. And x3 is 5 over 2. That would be the answer. So let me just do a sanity check here. I'm going to plug this into equation 1. Negative 5 over 2 plus 2 times this would be 6 over 2, so that would be 1 over 2. 1 over 2 plus x3 would be, which is 5 over 2. 1 over 2 plus 5 over 2 is 6 over 2, which is 3. If I had room, I might have written it out just to double check, but turns out that this works out correctly. x2 minus x3 is negative 1. Let's verify that. x2 is 3 halves minus x3. x2, 3 halves minus 5 halves is negative 2 halves, which is negative 1. And I'll let you check the final equation. So this is the correct answer for the system of 3 equations here. Okay, last one for this section. This is our first word problem. And once we set up the word problem, the solving of it is going to be very, very simple. So I think the toughest part might just be setting it up, because English is a tough language to work with. Let's give it a shot here. Teresa purchased books from an online bookstore. Each book was chosen from either the $1 basket, the $2 basket, or the $3 basket. Based upon the following information, determine how many books Teresa ordered from each of the 3 baskets. So we need to know exactly what we're looking for. How many books from each of the 3 baskets? So before we even look at anything, I know what my 3 variables are, the definitions will be. Let's first let me draw this will be the $1 basket, the $2 basket, and the $3 basket. So she's choosing books from these 3 baskets. And I need to know how many from this one, how many from this one, how many from this one. So what do? Let x be the number from the $1. Oops, the number from the $1 basket. Hope you can read that. Y is going to be the number of books from the $2 basket. Z is going to be the number of books she chooses from the $3 basket. So those are the variables we need. Well, here's the information we're given. We have to set up 3 equations and able to solve for these 3 variables. What do we get out of part A? She selected 5 books at a total cost of $10. Well, the first part of that, I'm going to stop with just this underlined part. She selected 5 books. What does that tell us? Can we make an equation out of that? Well, absolutely we can. All of the books that she selected, she selected X of them from this basket, Y of them from this basket, Z of them from this basket, and she selected a total of 5 books. So I know that X plus Y plus Z has to add up to 5. That was the easiest, I think, of the equations. Now, what can we do with this? 5 books, but the total cost of the books was $10. What equals 10? The price of those books, of all the books she got. So how much is the $1 basket? Well, there's obviously $1. So if she selected 2 books from here, it would be $2. If she selected 1 book from here, it would be $1. Plus, how much is the $2 basket? Well, $2. And 3. So the number of books she chose from the $1 basket, that many dollars, plus $2 times the number she chose from the $2 basket, plus $3 times the number of books she chose from the $3 basket, adds up to $10. All right, so in the next two, part B and C, we need to get one more equation. B, the shipping costs were $2 for the books here, the $1 books. It's $1 for each of the $2 and $3 books. So these cost $1 to ship, this and these ones and these ones. Can't get an equation out of that yet until we look at C. The total shipping was $6. So that means that, let's see, the shipping for the for the $1 books was $2. So $2 times the number of $1 books plus Y plus Z. I left off the 1 for the coefficients there because these are $1 each. That's 1Y and 1Z. Adds up to 6. That's the toughest part of this this problem, is just setting up this system of equations. And now we might as well go ahead and solve it. Well, let's notice that if I call this one 1, 2, and 3, I'm going to write equation 1 again, x plus y plus z equals 5. And then I'm going to take equation number 2 and multiply it by -1, because that's going to allow the x and the negative x to cancel out. I'm going to eliminate the y from those two equations. So I will say -1 times equation 2. And that would give me a negative x minus 2y minus 3z equals -10. So let's add them together, and this x variable disappears. When we add them together, we get a negative y, and then we get a z and a negative 3z, which would be a negative 2z equals -5. So as I've done before, if we wanted to, I don't know if we need to, we could call that equation number 4. It's a new equation. And now let's use equation 1 and 3. Instead of equation 1 and 2, let's use equation 1 and 3 to eliminate the x. So I'm going to write equation 3 here. Equation 3 is 2x plus y plus z equals 6. And I'm going to write above it, I'm going to write equation 1, but multiply it by -2, because that would give me a negative 2x right here. So -2 times equation 1. I forgot to write equation there, but you know what I mean. -2 times equation 1, and this is equation 3. So that would be -2x minus 2y minus 2z equals -10. I multiplied equation 1 by -2. And the x's will go away, and we'll get our second equation that have just a y and z in them. -2y plus y is -y. -2z plus z is a -z equals, and -10 and 6 gives me a -4. That could be my new equation 5. So I'm going to use equations 4 and 5 to solve for y and z. So maybe right underneath 4, I'd like this to be a positive y, so that the negative y and positive y would cancel out. Let's do negative 1 times equation 5. They would become y plus z equals 4. And the y's cancel out. Negative 2z plus z is negative z equals, add these two together, you get negative 1. So that means z is equal to 1. Now let's go back and look at these two equations again and figure out what y is. So looks like this one down here is a little bit easier to work with. If z is a 1, we get y plus 1 equals 4. Y plus 1 equals 4. That means y is equal to 3. All right, now we can go back to any one of these three equations and determine what x is. The first equation says that x plus y plus z equals 5. That's because y is a 3 and z is a 1. So that's x plus 4 equals 5. So when you subtract 4 from both sides, you get x equals 1. So the solution, if we wrote it as a 3-tuple, would be 1, 3, 1. And notice that the number of books, number of $1 books, number of $2 books, number of $3 books, it adds up to 5. So that was equation number 1. 1 plus 3 plus 1 is 5. And let's see, the 5 books cost a total of $10. So $1. These ones are $2 each. So 3 times 2 would be 6. 1 plus 6. And then one $3 book. 1 plus 6 plus 3 adds up to $10. The last equation, what was that one? That was the shipping, I believe. Yeah, the shipping adds up to $6. This book costs $2 to ship. This one and these three and that one cost $1 to ship. So 2 plus 3 plus 1 gives us 6. So we double checked it. 1, 3, 1 satisfies all three of these equations. So we're done.